All right, children, so this is going to be your lesson 10, 1-2 lesson video. Okay, and I'm running a little experiment this time. I have a live audience, so go ahead and give a round of applause. Okay, so my live audience is here maybe to ask questions and or tell me what I'm doing is confusing or just to watch. Okay, so what we're going to be covering in this video is quadratic functions, determining them based on the graphs and 3 points. Okay, first couple things we're going to look at is vertex form of a quadratic versus the standard form. Then we're going to look at how to identify quadratic functions based on the graph and how to determine them when we're given 3 points. Okay, so first, let's talk about standard form versus vertex form. Okay, so standard form of a quadratic is given thusly, and I hope I'm being loud enough. I feel like that mic's not being good. But that's supposed to say f of x is equal to ax squared plus bx plus c. Y'all should be very familiar with that. Okay? Well, maybe not y'all younger kiddos. Okay, then you've got the vertex form. Okay, and you'll see why it's called the vertex form. This form should look familiar. Okay? This one should look familiar just because of what we call completing the square. Okay? Okay, so vertex form is going to be what we talk about predominantly here in this video, or at least on this section, right? So let's talk about why it's so important. So if I have a Cartesian coordinate plane, there's x, here's f of x, and we'll go ahead and just say that that's equal to y. We ought to know that by now. Okay, so if I have your standard parabola, right? Standard parabola. It's going to look like this. Okay? And there's a number of reasons that it looks this way. Part of the reason is it's opening upwards because of this number right here. If a is greater than 0, meaning it's positive, that means it's going to open upwards. Okay? If a is less than 0, meaning it's negative, that means it's going to open downwards. Okay, so for example, if I had a little negative sign here, right, if it was negative a, it would open down like so. Okay? Another thing about a, go ahead and erase that for now. Another thing about a, as far as transformations go, the larger a is, the skinnier that your parabola is going to be, for lack of a better phrase. Okay, and what this means is, so let's say a was bigger than it is now. Let's say a was 2 originally, and now it became 60, right? That means our parabola is going to get skinnier because it's increasing more quickly. Okay, it's increasing faster. You guys are a great audience. Okay, so it would get skinnier, right? As a gets larger, as a gets closer to 0, as a gets closer to 0, our graph gets wider. And I'll use a different color here. Okay, so if we change a to something closer to 0, like a fraction, right? Let's say we had a over, I don't know, 18. That would make our graph get wider like this, meaning it's increasing slower, okay? As x approaches plus or minus infinity, it's not increasing as quickly, all right? So let me erase a little bit. Let's talk about the other components of vertex form. So you've got, besides the a, you've got an h and a k. Okay, that h and that k is super important because it tells us the vertex, hence vertex form. So again, I've got x and y of x. Okay? And I have some parabola. Let's go ahead and say like this. Okay? There's an important point on every parabola. Namely, its minimum, or if it's oriented going downwards, you can also say that this point here is a maximum. Okay, and it gets a little more complicated than that, and we'll show it here in a second. But anyway, you have either a minimum or a maximum. Either way, these two are both a vertex. Okay? Not as fast. Come back. Okay, these both are a vertex. Okay? Your vertex is given by the point h by k. Okay, so in both these instances, this is hk. Okay, that is your vertex. Your vertex will always be a minimum or a maximum. And if you remember from geometry, a vertex is like a corner. Okay? It's important to understand what a vertex is. But that is why it's important to understand vertex form. Okay? Because what we get from that is h. If you remember from transformations of the absolute value functions, h is like our left or right shift, right? Okay? If we have, for example, x minus 9 squared like this would be a shift 9 to the right. If it was x plus 9, however, if it was x plus 9, that would be a shift 9 to the left. Okay? This guy right here, the k is your up or down shift. Okay, that's your up or your down shift. Okay, if k is positive, you shift up. If k is negative, you shift down. All right? So more or less, that pretty much covers vertex form. We need to elaborate a little bit further, though. Okay, because you're going to see some instances where you may not have f of x. You may have f of y, meaning you may not have x as your independent variable. You may have y as your independent variable. Okay, and what that's going to mean is instead of your parabola opening up or down, it's going to open either left or right. So what do I mean by that? So this is x, this is y. What's up? Oh. This is x or y, right? And let's say I had a parabola opening like this. Okay? My vertex would still be here where you would expect it, but it's a little bit weird because it's sideways. Okay, it's sideways because what we have is a function of y and not a function of x. Okay? So that means we have this. We have y minus k. Whoops, ran out of room. It's hard to not write giant with this bigger pen. Oops, that should be okay. And what happens when you have a function of y? What happens whenever you have x depending on y is that your h and your k flip around. So this would be minus k, this would be plus h. Okay, so this vertex, it would flip. So it would become k, comma, h. Okay? What also changes, if a is greater than 0 or it's positive, that means we're going to open to the right. Okay? If a is less than 0 or negative, that means we're going to open to the left. All right? So it's pretty much the same idea. Okay, pretty much the same idea, except we are kind of flipping our vertices. Okay? Trying to think about covered everything. It's a little different than when I'm just sitting down doing this at the tablet. Okay, so let's look at some actual numerical examples. That's what I'm leaving on. I really, for your sake, Ben, since you're trying to take notes, I really hope the audio comes out okay. Because it's using my laptop mic right now, which usually works pretty dang good. But I guess we'll find out. Okay, so let's say I had a parabola like so.
How do we know which way it's going?
8. So it depends on two things, right? So if you have a function of x, it's going to open. So if you have f of x, if you have a quadratic formula or you have a quadratic function, right, that is a function of x, meaning x is the independent variable, that means it's either going to open up or down.
What I meant was, how do you know if it's going right or if it's going up or down? Like, how do you know if it's going to be a
This right here. So if I have f of y instead, meaning I have x as a function of y equals, let's say, y squared. That would be a sideways parabola opening to the right, because a is greater than 0.
I don't like which one it is, but like if you're given a vertex, you're not going to be able to tell it.
You're not going to be able to tell. No.
Okay.
You're going to have to know a little bit more information. You're going to have to know stuff like that.
Okay.
Okay, you're going to have to know what is that a term. That's kind of like our scalar. Okay, good question. But you're not going to get any questions quite like that. Okay? All right, so this one right here that I drew for example, okay? So it's opening upwards, so that means my a is going to be greater than 0. So that means, in theory, my a could be something like 2, right? And then I have x. Now, did I shift left or did I shift right? Well, I shifted to the left. Okay, so that means I'm going to have a positive. That means I'm going to have a positive or a plus h, right? So this is going to become x plus, we're just going to call this, let's just say that that's 5. That's x equals negative 5. Okay, so we would say x plus 5 all squared. And let's say this right here is negative 6. Okay, so that means my vertex is negative 5, negative 6. So that means I'm going to have x plus 5 all squared, and then I'm going to have minus 6. Okay, a x minus h all squared plus k.
Okay. So if
All right.
it's a minus h, it goes to the left. If the plus is h.
Yeah, it's just, you remember the absolute value functions? Remember how they would shift? It's the exact same idea.
Like it's a plus, if it's minus h,
Yes.
minus negative.
Yes, exactly. That's exactly why. Okay, now this number did not have to be 2. All I'm saying is it can be 2. Why? Because 2 is greater than 0, and my parabola is opening upwards. Okay? And trust me, we'll see more examples and get more practice with this. But again, I'm just trying to keep this video brief. Okay? So we already went over a lot of this. All right, so let's look at determining quadratic functions given 3 points. Okay? So what I've got, x1, y1, x2, y2, x3, y3. Okay? Given these 3 points, and assuming that we know you have a quadratic function that passes through these 3 points, you can calculate what quadratic function exactly passes through those 3 points. Okay? So the way we would do that, let's go ahead and say, actually, let's keep using green. Let's go ahead and say this point 1 right here, right? This is where we are going to use standard form. Okay, so our function has to be in the form ax squared plus bx plus c is equal to f of x. Okay, what we can do is plug in our values for x and y into f of x. So let's go ahead and do that. So if y is 2, that means f of x is 2. Okay, a we don't know, but we know x is 1, right? And again, I'm doing this x1, y1, this first point. So x is 1 squared plus b times 1 plus c that is unknown. Okay, so that's going to give me a plus b plus c is equal to 2. Okay? Now let's look at this next point. So we're saying f of x is equal to 0 when x is 3. So a times 3 squared plus b times 3 plus c, which is going to give me 9a plus 3b plus c. So I'm going to come over here and write this guy, and you can kind of tell already we're kind of forming a system of equations, and that's exactly what we're doing. Okay? We're going to form a system of equations, and then we're going to solve for what is a, b, and c to plug into our standard form here. Okay, so one more. So in this case, y is 6, and that's equal to 6 whenever x is 3. So a times x squared plus 3, oops, not 3, it's copying from the last line, plus b times 5 plus c. Okay? And Ben, while I've got you here, follow along and just make sure I don't do anything stupid. That way I don't have to re-record this video. Okay, so, because that's very possible, you know. So, 6 equals 25a plus 5b plus c. 25a plus 5b plus c equals 6. And now we have a little 3x4 linear system of equations. Okay, so while I'm erasing this, the way we're going to want to solve this, obviously, is with good old-fashioned elimination, because substitution is going to suck. Okay, the first thing I want to eliminate, what do you want to eliminate first, man? A, B, or C? I'm going to use the green and the blue. What do you think? You want to eliminate B? You want to eliminate C?
Like, would you want to get rid of the equals first? Would you want to take the equal 0 first?
No, these are not quadratic.
Not take equal 0, like the first at the bottom. You could get rid of the 2 and the 6.
No, we want to get rid of some letters first.
Oh, okay.
So the simplest thing to get rid of, let's get rid of the C's.
Okay, yeah. Okay.
So I'm going to multiply this guy here in green by -1. Okay, so that's going to give me negative a minus b minus c equals -2. And we're doing that because that's going to eliminate, we'll see here in a second, with this guy beneath. Okay, so combine everything down. -2 minus c plus c, that's gone. Minus b plus 3b, that's going to be plus 2b. And minus a plus 9a, that's going to leave me with 8a. Okay, so what I've got for my first little 2 by 3 is going to be 8a plus 2b equals -2.
Yeah, I get it now. Why you did
Yeah, this is review now, right? We've done this before.
That's just, it was a lot. I can really.
It's been a while. Okay, so we want to eliminate C again. We want to eliminate C again. And the simplest thing to do would be to do the exact same thing, except using these two that I highlighted here in green. Okay, so I'm going to multiply the green guy by -1 again, so that it eliminates the C from the pink. Okay? So let's do that. So I'm going to have -a minus b minus c equals negative 2. We can combine everything down. Plus 6 minus 2, that gives me plus 4. Plus c minus c, that eliminates. Plus 5 minus 1, I get minus 4b. And plus 25 minus a, that gives me plus 24a. Okay? So my little baby system over here, 24a minus 4b equals positive 4. Right?
Divide them all by a factor.
So now I can eliminate b the easiest. What do you think? If I just multiply by 2 on top. See that? Okay, so that's going to give me, and I'll use a different color. I'm trying to keep color coding so that things don't mix up so badly. So this guy is going to give me negative 16a. Okay, this is going to give me minus 4. Whoops, why am I multiplying by positive? I should just multiply by,
Multiplying by negative?
yeah, I should just multiply by positive 2, right? Because that b is already positive. I don't know what I was thinking there. So this would be 16a plus 4b, which is what I want. And then over here, I'm going to have minus 4. Okay? All right, so now we're going to combine down.
Wait.
What did I
think you
do?
made a
What did I
mistake.
Huh?
I think you made a mistake.
What did I make?
You should have multiplied by negative.
No, I want this guy to be
Actually,
positive.
no.
I want this guy to be positive.
No. I have a question. Over here,
Where?
it's a 5b minus b, and you put a negative 4b. That should be a positive 4b.
Oh. So that should be plus 4b. See, that's why I have you.
So maybe you should multiply that top
I
one.
should multiply. Okay. So that should be positive. Thank you. Okay. So then, go ahead and change that back to a negative. See, there's some benefits to having an audience. Okay, so y'all that were watching the video probably caught that also. So that's going to give me minus 16a, minus 4b, and plus 4. Okay? So, plus 24 minus 16, that gives me plus 8a. This eliminates, and I have 8a equals 4. All I'm going to do from here is divide by 8.
Equals 8, Mr. Pound.
Equals 8. Oh my goodness. It's late in the day. Divide by 8 on both sides. A is equal to 1. Oh my goodness. Okay. So, now, I can take this guy, right? And I can substitute back into one of these other guys. Okay? So I'm going to substitute it back into this one here in white, just because it has smaller numbers. Okay? So, if A is 8, I can go ahead and do 8 times 1 plus 2b is equal to negative 2. Right? Then I'm going to subtract 8 from both sides, because 8 times 1 is just 8. So that's going to give me negative 10. Okay, then I'm going to divide by 2 on both sides. B equals negative 5. Okay, so I have 2 of my answers. Almost done. Almost done. Okay, now I'm going to substitute A and B back into this guy here. Simplest one. So 1 plus negative 5 plus C that I don't know yet equals 2. 1 plus negative 5, that gives me negative 4. Add 4 to both sides, C equals 6. Okay, so what does this mean? What this means, plain and simple, is A is equal to 1. So this is just going to be x squared, right? What was B? Negative 5. So I'm going to say minus 5x, right? That's B. And on C, our little constant by itself, is 6. So I'm just going to say plus 6. And there you have it, my quadratic function from my 3 points. Okay? And again, we're going to be solving systems, right? So you saw mistakes that I made. So be very mindful of that. All right, kiddos, that's all I got for this video. Hopefully the audio turns out okay. Goodbye.